Next, I'm going to show you the command Is-BackwardsCompatible. This takes two MIB files, newer and older, and give you the information if they are compatible or not by printing true or false, or if you use a details, it will give you also the detail information why it is not compatible, or if it's compatible, what's newly added, but still is compatible. Now, to understand what we mean by backwards compatible, we need to take a look at some example of the MIB. And to save time, we will not use the import MIB command, but import CSV, because we already have created a CSV file for this OCUM, and we have two versions there, 6.2 and 9.4. So we're gonna import that to show what the script is looking at in figuring out if those are compatible or not. You see, it's kind of big and it will take some time just to print out, even though it's already compiled. The question is, how we gonna figure out and define what is backwards compatible and what is not backwards compatible. So if we have two MIBs, they contains a set of objects, like object types, object identifiers, trap types, notification types, etc. So the first thing to check is that all those objects, object types, identifiers, traps, etc. are defined also the same way in the new MIB. So if there are any additional objects in the new MIB, it's fine, but and it will be compatible. The problem will be if there is some object in the older trap which is not in the newer trap, or which have a same name but changed OID. That wouldn't be compatible. The reason is that if you have it compatible, it doesn't matter which version of the software is sending you trap, you will be still able to understand it with that one MIB. If you are having two versions of the software sending you traps and the MIBs are not compatible, you will not be able to understand it with one MIB, but you will need two MIBs. Another thing which is the script checking are in the traps or notification types, the objects or variables. Those are the variables which are sent inside the traps, and their name actually correspond to object types defined in the MIB, either in the same MIB or the different MIB, but still they need to be defined in the MIB. And because a lot of monitoring software is dependent on the order of those, the script is also checking if they are coming in the same order. So takes the trap from the old one with the name and OID and check if the same trap with the same name and same OID exists in the new MIB, and then it takes the variables from the old one and check if they are in the definition of that new trap in the same order as they are in the older. If there would be a new variable in the newer definition, that's fine. It's okay. It doesn't matter. But if there would be some, for example, this object, if it would be missing in the new definition, it will not be backwards compatible. So let's see the simple example. So the newer MIB is OCUM 94. The older MIB is OCUM 62. And because this will print true, because they are backwards compatible, we also print out the details to see what are the differences. And you actually see it prints a lot of differences. Mainly it's just saying that the new object is added, which is fine. It's new object which is added. And it then prints out it's a true. If we reverse the order, the older and newer, it will actually not be a compatible. The reason for that is that in the and now that's in the quotes in the newer, because it's really not the newer, it's older. The definitions, those definitions will be missing, right? So if I reverse the order now, they will not be backwards compatible because this one which we marked as older is actually containing something which the newer is not. So you see, as I've said, it's false and the object is missing. Object missing in newer MIB. So that's exactly what we expected if we added in the wrong order.